Hi everyone, so we are in section 5.4, 5.5 of the pink packet. We're on page 73, and there isn't enough room for some of the things I need to discuss with you, so I want you to grab your cheat sheet that you've been working on, and we're going to make a little section for 5.5 and go over this. So let's recall the things that we already know about graphing, because we did that in our first section. And in our first section, we used this format. Okay? And B, if you remember, was our y-intercept. I will do some abbreviating. And that's when x is 0. And then G is called the growth factor. And when we're making our table, that's just what we multiply by to get more values in our table. And as far as the table goes, I'll put that over here. We are going to be using these values when we graph. But what we're going to do is we're going to start to see some changes. So what I'm about to write, I really don't want it to confuse you, because when we have graphed, we have used A, H, and K. And so I want you to see how this would look with A, H, and K with it. So if we made this have the same letters of A, H, and K, right? Let me separate this out. We would have Y. And instead of, we would see the negative, which remember is the flip. And then we would see A, which is the stretch or the compress. And I think I'm going to put shapes around these to really get you to see this. So this is going to be this now. All right? So y-intercept, that's going to be your beginning amount, but that's where we're going to address it as the flip and the stretch and compress. Then you're going to see G, which we'll leave that as it was. So hold on. G. So G is still G, right? No big deal. And then we normally see after that our, our left, right, up, down number. And our left, right number, H, was always contained in something in the past. Parentheses, absolute value bars, a radical sign. So here our exponent is going to be contained in the, H is going to be contained in the exponent. And just remember that H is what we do when we go left or right. Okay? And then we still have K added on at the end. And that would tell us to go up or down. So while this is great, this is primarily what we're going to be using. And so now what we're going to do is we are going to add to this. So G is called the growth factor. It's what you multiply by, right? It's also just called the parent function, for lack of better words. And this is where you're going to be able to tell the shape, if it's growth or if it's decay. And you're going to know, because if G is bigger than 1, you're growing. And if it's in between 0 and 1, you are decaying. So let's now take this stuff and just add the last part to graphing. And we're going to put the minus H, just like where it was, and the plus K as it was. So I do want you to see that there is A, H, and K, but because of how we introduce graphing, we're going to switch it up a little bit. All right? So with that, not so important to know. So I'm just going to lightly, not scribble it out all together, but I don't really know if that's what I really want you to focus on. I want you to focus on this. So let's try some of these graphing from beginning to end. So the first thing I'm going to do is just, make my table like we did before, and then we're going to worry about, the left, right, up, or down, because this time when we make our table, we're going to build in the flip, the stretch, and compress from the very first step because of this y-intercept. All right? So let's start. First thing is, the parent function is just 2 to the x. So if I do want to add a y-intercept, What I'm missing is the 1, so I could change it if that helps, like that. So when I make my table, and again, we're always going to use the same x values of -2, -1, 0, 1, and 2. What I want to do right now is just first identify the shape. Is it growth or decay? Identify the y-intercept and get my table filled out. So what I'm going to be ignoring right now is the h and k. This is what we didn't see when we first started graphing. So my y-intercept is 1, and to get all the other points, as x gets bigger, I'll multiply by 2. So I begin with 1, and then I'm going to start multiplying by 2, multiply by 2, and then if I'm multiplying by 2 this way, I would divide by 2 this way, so a half divided by 2, and half divided by, so 1 divided by 2 is a half divided by 2 is a fourth. Alright, so as you can see, as the x's get bigger, the y's are getting bigger, so this is growth. And I should know that it's growth because I'm technically multiplying by 2 each time. So there's the shape. And I could graph those, but what I want to do is realize is now I am going to have these other transformations. I'm going to have 1, which is going to tell me to move right 1, because you always do the opposite of h. And then 3, which is going to tell me to go up 3. So what I'm going to do is start with these points, probably put this one in there, because that's pretty simple to do, and not keep them there, but I'm going to move them right 1 and up 3. Now before I do that, I do need to go back and talk to you about that horizontal asymptote, which was here. And the horizontal asymptote, you know, is just along the line, the x-axis where y equals 0. That is also going to transform, or translate as I should say. So it will be affected by these, but it won't be affected by both, because if I take this and just move it right 1, nothing looks any different. But if I take this and move it up 3, then it takes on a whole new look. So the first thing to realize is that your up 3 is going to take your wall and move it up 3 to right there. So now I have a new horizontal asymptote, which I'm going to put here, of y equals 3. Let's go ahead and get this graphed. So I'm going to start with 0, 1, which is technically here, but it's not going to stay there. It's going to go right 1, up 3. And then 1, 2 will go right 1, up 3. And 2, 4 will go right 1. And then up 3 doesn't even fit on the graph. So that's why I do want to put in this point of -1/2, and it will go right 1, up 3. And then that's pretty good. As long as I know the shape, I know to make this shape that's going to look like, I guess more like a J. And here we go. So it's going to coast right along and above my horizontal asymptote, and then it's going to go up. And when you do make it go up very steep, very fast. So let's talk about domain and range again. I'm going to get my little whiteout tape. So hopefully from before you will remember, you'll see this pattern. So this is just where I can put my stuff for my arrows. This one is going right and up. And this one is going left, so I do have a negative infinity, but it's not going down. It's going to get stopped at my wall of 3. So when I do domain and range, it's -infinity to infinity, or you could write the all real numbers. And then my range goes from 3 to infinity, but since I don't want to include 3 because it can't touch the wall and it can't cross the wall, I don't want to include the 3. I'll put parentheses. And as far as the end behavior goes, yeah, let's go ahead and sneak that in there. So as x is getting bigger, what is my y doing? What is my f of x doing? It's going to infinity. And then for the other one, as x is getting smaller, then for f of x, we're going to change it to an arrow that it approaches 3. Whoops, sorry, you couldn't even see that. It approaches 3, but it's not quite at 3. Okay? So I don't want it to equal 3 because it's not going to get to 3. So it's going to get close to 3. That's what the arrow is going to say. And it's graphed. That's it. So essentially what we're doing is graphing like we did before, and then we're moving it left, right, up, down. So let's take a look at this one. So as far as my table goes, you know, this is what we graphed last time. I've got a y-intercept of 3. and then I'm going to multiply by half. This 2 is just saying everything's going to move down to when I'm done. So I'm going to put my table here. Let's see, so -2, -1, 0, 1, and 2. And again, my y-intercept is 3, so that's where I will begin. And then I'm just going to start multiplying by half. So 3 times a half. I'm going to pause this and adjust my screen. All right, I'm going to zoom in a little bit. So 3 times a half is just 1.5, and 1.5 times a half is just 0.75. You can think of $3 cut in half as this, $1.50 cut in half is this. So technically what I'm really doing here is dividing by 2, which means this way I would multiply by 2, which gives me 6 and 12. All right, let's go ahead and get these graphed. So remember, these are not going to stay where they are. They will be moving down too. And if you notice, the points as x gets bigger, the values are getting bigger. So this is decay. And I know that as well because this is in between 0 and 1. So this is the shape I should expect. And this time I'm going to graph my horizontal asymptote last. So -212 won't fit, but -1,6 will. But it's not going to stay there. It will now move down 2 and end up right here. 0,3 will also move down 2. 1 and 1.5 will move down 2, end up right there. And then for me, that's pretty good. I'm not going to graph this. But the wall will move down 2 and end up right here. So again, I'm going to have a horizontal asymptote of y equals negative. Sorry, you can see that. Y equals -2. And now I'm going to make sure I get that exponential shape going down. And when I get to the wall, just have it go right above it. Don't let it touch it. Now, as far as domain and range goes, domain is always going to be this in exponential functions because going left and up right here. And then for this one, let me put a little white out tape so it stands out. It's going right. But when it goes down, it's going to get stopped at the wall. So the range is being affected always by the horizontal asymptote. And because range is y, and our horizontal asymptote is y, the letter y that is, that's why that's happening. So my smallest y to my biggest y, parentheses. So this will always be a pattern that your horizontal asymptote will be the first number, and the second will always be infinity. Again, and behavior. So this time as x gets bigger, this time my f of x will get close to -2, but it won't become -2. And then when x is getting smaller, right here, my f of x is going to become infinity. And you could even put an arrow with the infinity if you want to. Okay, let's go to our last one. So this one is set up a little differently. So it's 4 minus all of this. So what we're going to do is we're going to rewrite it. So the +4, +4 is at the end. Here's the 2 with the x plus 1. And when you see that negative, this can never be a negative number. This number, your growth factor, is either bigger than 1 or in between 0 and 1. What's happening here is technically there is a -1 sticking out in front. So when we make our table, again, leaving out h and k, here come those x values. My y-intercept is -1, and then I'll start multiplying by 2. So multiply by 2, multiply by 2, and then I'll divide by 2. So if you think about this shape, this is technically going back to this. This is why I don't know necessarily the best way to teach this one. This negative is really growth flipped. And so if you think about it, this is growth, and this is a negative that's flipping it. This is the growth shape. And it's just going to flip over like this. So when we're done, this is going to be the final shape, which is a little different for us. But hopefully we're going to be able to see that. So let's get these graphed, then we're going to get our wall. So I'm going to start with 0, -1, but it's not going to stay there. It's going to go up 4, and up right here. 1, -2 will go up 4. 2, -4 will go up 4. And hopefully you're starting to see that curve, but this might be a good time to throw these in there. Here's -1 and -0.5, and it will go up 4. And even this one, I'm going to throw that one in there. -2 1/4 would just end up right barely there. And then my wall will end up right there. So here is your shape. All right, let's do the arrows. So I'm going to put a little white out here so you can see this. So for this one, it is going left, but it won't go up. It's going to get stopped at 4, and this one is going right and down. So again, domain, -infinity to infinity, or you could put all real numbers. And then when I do my range, this time I have a -infinity because of that flipped part. So it goes from -infinity to 4. And I'll put my horizontal asymptote in there. That is at y equals 4. And then we can do our end behavior. So when x is getting bigger, our f of x is going to infinity, or sorry, -infinity. And when it's going to -infinity, now our f of x is going to go towards, there's an arrow, 4. And then just throwing in that whole e. So e, we're not going to be concerned about graphing any points really. We're just going to be more concerned about the general shape of it. So as far as e to the x, the main thing we want to understand is that you could probably get 2 points here if you really want to. So let's start out by making that whole table, and then I'll show you the ones that we're going to focus on. So again, to make this match the other ones, I need a y-intercept, so 1 times e. There's my y-intercept, and then this is what I should be multiplying by each time, so about 2.7, so about 3, and that's it. Those are the only 2 points I really want on there, 1 and what e is worth. So about 2.7, close to 3. And then we're going to remember that this means we do the opposite. We're going to go left 3, and we're going to go down 4. So we're going to leave these out for e. Here's 0, 1. Just imagine it goes left 3 and down 4 and ends up by about there. I don't know why there are not grids on this. And then 1 with 3 is just going to go left 3 and down 4 and end there. And again, this is bigger than 1, so this is a growth shape. Here's that horizontal asymptote. I would have put points on here, but something like this. When it's something like this, and let's take that 12 out. That's way too big. Let's change it to 2. So there's the y-intercept, but remember, the only way to show decay here is if we have a negative exponent. So what we're really seeing is 1 over e to the x power. You're fine to leave it like this, but you have to realize that this is decay. And now this just says it's going to go up 2. So if I just focus on my very smaller table of values, we're just going to worry about 0 and 1. So I begin with 3, right? And then technically 1 over e, this is about 3. So I'm going to kind of be where I should be multiplying by 3, I'll dividing by 3-ish. So it's about 1-ish. It's, again, this ish part. It's close to it, but it's not quite there. So remembering that e is about 3, so this means I should be multiplying by about 1/3 or dividing by 3. I hope that makes sense. And so here comes my wall. I'm just going to go ahead and move my wall here up 2. And then 0, 3 would just move up 2, and 1, 1 would move up 2. Let's see, I'm going to pause, hold on. All right, sorry for the pause. I've done too many videos today. So again, this would be much better if we actually had grids here, because if it's at 1, 1 and it moves up 2, it's actually going to be, it will be above this line. And then again, it's decay, it's coming down like this. So sorry about that there are no actual numbers on here that there is like that. So I think we're going to call it as far as our video notes go for this part. Let's just take a real quick look at this one, and then we're going to be, wrapping this set of notes up. So actually I'm going to stop this part of the video and do a second video for the next page.